Hi, I'm Claire, and since the last milestone, I've gotten my robot to start balancing. So the first thing I did was start implementing a PE-only PID controller, but while I was doing that, I had some issues with the robot because it was jittering really violently back and forth, and we spent an entire week trying to sort of figure out what was the root cause. There were a lot of theories going around, like it was the visible PWM because the processor wasn't running fast enough, or I was maxing out the current on the power supply, which we tried to solve with batteries. And the final one was that the accelerometer was getting confused because when we whacked the robot, it would start jittering. So we sort of tried a bunch of band-aid solutions. Like I tried switching out the Arduino Uno for a Due because it had a faster processor, but I couldn't get the IMU library loaded onto it, so we sort of put that aside. I just tried to keep tuning the PID constants. That didn't really work either. And then the last thing I tried was limiting the max motor output, which dampened the oscillations, but it still didn't really solve the problem. So over the weekend, I asked for help, and we basically decided to switch out the Kalman filter, which I was originally using to filter out the sensor readings, for a complementary filter, because it's a lot simpler to tune. The Kalman filter has a lot of fluff around it, and I don't have the math to quite understand what it means, so we just used the complementary filter. It worked a lot better. The sensor readings were a lot smoother. So then we continued tuning the PID constants, and it was jittering, but it was jittering because of the PID constants, and they weren't tuned well enough. Because when we graphed the sensor readings on a processing sketch, it was very smooth. So the next thing I did was implement P gain scheduling. So gain scheduling is when you sort of tweak your gains while your system is changing. So there's a small angle band here near vertical where it was jittering around. So we decided to sort of dampen the response based on the P gain. And we tried a linear gain scheduling thing. Worked okay. It was still jittering a bit, so we sort of tried to damp it even more really near vertical. So we did a quadratic, and that worked out pretty well. So then the next thing was that it was balancing, but once it got past a certain angle, it couldn't catch up because it was maxing out its speed. So the next step was to implement an outer speed PID loop that says I want to stay still, I want to have a speed of 0, so what should my angle set point be? Passes that set point to the second PID loop, which says, okay, I want this to be my set point, now how do I command the motors with PWM? So that's what I've been doing, reading the encoders and calculating the speed, and then implementing that and tuning the PID constants. So here is it working. So it balances in place pretty well, and if I give it a push, it will resist my pushing and try to stay in place. And my next steps are to implement a third PID loop that takes the desired motor speed and sends a PWM command, because right now, as you can kind of see, it doesn't really move straight. It sort of turns sometimes because the PWM commands act differently on the motors, so I have to regulate that. And then my final step will be to add remote control to get this guy moving around.